So let me just write that out. So this is 5.7 financial models. It's A equals P 1 plus R over N to the NT. And the A is the amount now. The P is the principal. The principal invested, oh, not amount now, amount later. Amount later. Principal invested now. The R is the rate as a decimal, the interest rate as a decimal. The T is number of years, it's time. And the N, which is in actually two locations, N is the number of compoundings per year. So, for example, if they say, "Hey, we're going to come," this is compound interest for this is for compound interest. So this is the compound interest formula. They say, "Hey, we're going to compound this money monthly." Monthly. How many times per year is that? 12. So N would just be 12. N is number of times per year. And they say, "Hey, we're going to compound the money quarterly."
4.
That would be 4 times. N would be 4 times a year. We're going to compound the money semi-annually. That's only twice a year. Semi-annual is twice a year. Or daily.
Yeah, right.
300.
They only do that with loaned money.
And 65 times per year.
Yeah.
There we go. So there's the formula for compound interest that we'll use. I'll move on. It's on the sideboard as well, or maybe you want to see it up front. So let's try to do problem number 1. What was problem number 1? 600 invested at 2%. So everybody got that copied down okay? So number 1 says $600 at 2%. Compounded, what did it say? Quarterly for 4 years. Quarterly for 4 years. All right. So try to use the compound interest formula right here again. A equals P 1 plus R over N to the NT. So use that, plug everything in, and then use your calculator. Crank out the, what does that 600 grow to become? Compound interest. What does the 600 grow to become after 4 years, at 2% compounded quarterly?
So, would you have to convert percent to a decimal?
Yes, you got to plug in, you got to make that 0.02, right, for the R. You plug in the R, it's got to be 0.02 exactly. So what's the 600 first off?
The principal.
That's the principal, right? That's the amount invested now. The rate, 2% is 0.02. The N,
4.
yeah, because quarterly N is 4 times a year. And the T is also 4 for 4 years. All right, hit the buttons on the calculator. I'm getting $649.84.
For 4 years?
Yeah, make $50.
Oh, great. Makes me want to invest right now.
There we go. Is that good? Is that working out?
Are you being sarcastic? Oh, yeah, I'm being sarcastic. I was pretty sure.
The riskier your investment, the more you
Yeah.
Lose.
Or lose. Well said.
Yeah.
All right, so try that out. 300 invested at 2%, compounded daily for 2 years. So if you can get the amount.
Where do I get this?
All right, so the principal investment is
$300.
$300. The rate is 2%. What's the number of compoundings? Daily?
365.
365. And the T, the time is 2 years. So there we go. I'm getting $312.24. $12.24.
I made a whole $12 in 2 years.
Is that good? Is that making sense? You guys able to crank these out? Grab me if you're having trouble with your calculator. So notice these are in a zone. So you have to either multiply them ahead of time to get whatever that is, 730, I think, or put parentheses around them when you do the power. Remember, so that's what I mean. So it's not just denominators. Anytime you have more than one item in a zone, meaning numerator, denominator, or power zone, you either put parentheses around that whole zone or just figure it out ahead of time. So it becomes one thing instead of two. Right? If I just figure it out ahead of time, well, then it's just one thing. It's just 730. I don't need to mess with extra parentheses. But if you're going to leave it as two things, then you need to put extra parentheses around them. Otherwise, the calculator won't know. It'll only do the first thing as the power, and it'll think the 2's down on the main line. It won't know the 2's also up there in the power. Does that make sense? That's usually what gets people. So really remember that rule using your calculator. More than one item in a zone, continuously. There's the key phrase on this one. Continuously. For 4 years. Okay, so $50 at 5% compounded continuously for 4 years. Now, we don't have any way of doing continuous compounding, so we use a different formula. We use what I call the Pert Formula. So this is what we use whenever they say continuous compounding. And it's actually easier than the other formula. So you might wonder, like, where'd the E come from? Yeah, that's a great question. Be glad to talk with you more and offstairs about that. But yeah, with continuous compounding, that's one of the places they first saw and discovered E. It comes about in continuous compounding. That specific number is exactly what you need for continuous compounding. So we'll just use the formula. So the amount. So when do you use this formula? Whenever the compounding is continuous. If the compounding is anything else, monthly, daily, weekly, yearly, whatever, then you use the normal, bigger formula. But if it's continuous compounding, which seems weird, like how do you compound even more than once a day? Yeah, even more than once a second. It's continuous. It's without stop. Continuous compounding. You use the Pert formula. So the principal, what's the principal?
$50.
The 50. So everything's the same. The E is just the special number E. R, what's my R?
0.05.
Yeah, 0.05. And what's my T?
4.
4 years. So hit the buttons on your calculator. The E is above the natural log, right? I'm getting $61.07. Getting that okay? Any good questions on that? There's the question. Find the principal needed to get $700 after 2 years at 7% compounded monthly. So first off, which of the two formulas are we going to use? The big one or the Pert one?
The big one.
The big one, because it's compounded monthly and is 12, not continuously, right? We only use the Pert formula for continuous compounding. So I'm going to use the first one, the bigger one, 1 plus r over n to the nt, okay? And now they're saying find the principal. So I'm actually trying to find P, huh?
Wouldn't you just divide by 1 plus R over N?
That's what we'll do.
the
To get the
N?
700, where's the 700 going to go?
A.
Yeah, does everybody get? That's the amount later that you're trying to get later. The 700 is the amount you want to get later. And the interest rate is 7%. Monthly N is 12. T is 2 years. Yeah, so there's everything plugged in. And we're trying to find P. Right, the principal. We're trying to find how much you got to put in the bank now. What lower amount? See you, Wendy. What lower amount do you got to put in the bank now that'll grow and become $700 later? So what am I going to do to solve for P?
You just divide the whole thing.
Divide by that whole big mess, yeah. And I was going to make that 24, that power right now. Boom, boom. That'll get P alone. Can you do all that in your calculator? I'm going to show you a faster way on Thursday, which I'm doing myself right now. I'll show you how to use the answer button. You can do it super quick, super easy. You don't have to worry about parentheses and all that kind of stuff. It's super fast, super easy. $608.60, 80 cents. You got to put $608.80 in the bank now. It'll grow to become $700 over time.
Yeah.